So in first lecture, Professor Suspita Roach, she discussed about basics of blockchain, and now today we will discuss in lecture 2 the fundamentals of IoT. So the full form of IoT is Internet of Things. So in this presentation, we will discuss why Internet of Things. We will discuss what is Internet of Things. Also, we will discuss where we used Internet of Things and how it works. So, before coming to the definition of Internet of Things, we will discuss that why Internet of Things. So, if you see the first figure, the person is lazy and the person is sitting like this. So, I can say that we are lazy. So, what we want? We want to control everything remotely. So, if you see the second picture, in second picture, the person is sleeping on a sofa, and what he wants to do, he has one remote control on his hand, and he is trying to eat the chips with the help of this remote control. That means he wants to control everything remotely, and with the help of this Internet of Things, we want to control everything remotely. We want to automate everything. We want to see data in real time. So what this person is doing with the help of the remote, the person is trying to control it remotely. He wants to automate everything with the help of some remote control or remote machine, and whenever I am pressing some keys, I can see the work in real time. That means when I press the key, that food is automatically go inside my mouth. So this is IoT. So now we'll come to the proper definition of Internet of Things. So what is Internet of Things? This I have copied from the Wikipedia, but what is Internet of Things? So Internet of Things is a network of physical devices, vehicles, home appliances, and other items where it is like many IoT components are embedded with electronics, software, sensor, actuator, and also we give connectivity to these devices, which enables these things to connect and exchange data. So what are the three main terms here? This is the network of physical devices. So if you see, this is a network of physical devices. We have some home application devices. The student is reading with the help of some laptop. It's connecting to the Wi-Fi. You do some type of irrigation with the help of the network of physical devices, and also vehicles are vehicle, home appliances, and other items which are embedded with electronics. These devices are embedded with electronics, small electronic devices, software, sensors, actuator, and also we give connectivity to these devices so that these many devices forms a network, and they connect with each other, and they can transfer data with the help of the Wi-Fi or any internet service, which enables these things to connect and exchange data.
Ma'am, what if we are connecting them through Bluetooth? Then it is also a...
That is also a part of IoT.
Okay.
We can connect, but in this case we can exchange data as well. Like suppose I want to control something automatically without the physical intervention. I can control that. So I want to give water to my plant. So sitting in my office also, I can use that software. I can automate that device, and from here also, if I press the switch, the water will be sprinkled to the plants. So what is Internet of Things? So if you see that first sensors, we use sensors, different types of sensors like temperature sensor, proximity sensor, different types of sensors. Then we also use local processing. We use some processor. We also need some storage device. We need network so that I can connect with all devices. We need internet to exchange data. We need cloud to store more amounts of data, and then we need cloud storage to processing. We need cloud for processing as well as for storage. So Internet of Things. What is the goal of Internet of Things? So the goal of connected. So connect the unconnected means earlier days we have only fridge. Those fridge are not smart fridge. Like we have washing machine. Those are not smart washing machine. Nowadays you can control your smart washing machine from any place, anywhere, or you have that's embedded the software. In that software you have programmed everything that the washing machine you can also put in quick wash or normal wash or hot wash like this, and the time is already set, and it will automatically take water, it will wash the clothes and it will dry the clothes within that hour. So like smart bulb or smart light, etc. So in in smart home, whenever you will enter the home, whether you have attached some sensor, when the sensors will check that someone is entering the house, automatically the light ons in that house. So that is a smart home. That is also one application of Internet of Things. So the goal of IoT is to connect the unconnected. So what is IoT? So IoT is a technology transition in computer network which allow us to sense and control the physical world by making objects smarter and connecting them through an intelligent network. So IoT is a technology transition in computer network. What it allows us to sense and control the physical world by making objects smarter and connecting them through an intelligent network. So connection of objects with machine, it improves efficiency, it improves accuracy, automation, it enables the advanced applications, etc. So origin of IoT, the term Internet of Things, it was initially coined by Kevin Ashton in 1999, and he told that in the 20th century computers were brains without senses. So what he told that in 20th century what we have seen that the computers were brains without senses. We have computers, but those computers we don't have senses in those computers. Nowadays with the help of IoT, what happened? They only knew what we told to them. That means suppose you are using a calculator, you are using a computer, so you have written a program, whatever program you will write, it will only do that work. You give some input and you will get output. So what is the difference in IoT? IoT is changing this paradigm. What it changes in 21st century, computers are sensing things for themselves. So it will sense, like as I said that in a smart home, when a person enters, it will sense that someone is entering the house. So automatically your light switch will be on. Okay, so light will be on, and whenever the person exits that place, again the light will be off. So now the computers are sensing themselves. Earlier we only program and we provide input and we will get output. So what is said that in 20th century computer was were only the brains without senses, and in 21st century what the computers are senses things for themselves. Then this is the technology roadmap of IoT, how it evolves. It evolves over time. Like in 1960, we have only communication, we can do only communication between hosts. So what happened that one computer evolved, another computer evolved, these two computers connect with each other, and this computer can transfer information to this computer. And then with time, they evolved number of hosts. So the computers are connected with each other. And then by 2000, communication between host and web. So again, we develop internet. After the development of internet, we can connect the computer with other computers and they exchange information. Like we are in India, we can send information from here to USA. Okay. So with the help of internet, and then we provide mobile internet, like communication between host, mobile and web. So earlier when computer developed, you have a computer static here. In a room you have a computer, and maybe in USA in your friend house you have another computer. We are exchanging information from one computer to another computer. Then when it got mobile, like while walking also you can send messages or you can exchange messages. Okay. Then mobile plus people plus PC means communication between host, people, mobile and web. So now with the help of web also people can transfer mobile, people and PC. Then next is communication between every object, host, people. So in this case, we have some identity through our some social pages, like we have Facebook, we have WhatsApp, we have Instagram. So this web is also connected to mobile plus people plus PC, and here Internet of Things, every objects can exchange information with every objects. Communication between every objects, like host, people, ATM, home, mobile, car and web, etc. They can communicate information. Like whenever you will do some transaction on the ATM, you will also get messages through your phone that you have done some transaction. Yes or no? It automatically you can withdraw money from your ATM. So communication between every objects are possible with the help of this Internet of Things. So initially when this internet developed, it was developed for people, Internet of people, and later it was developed for Internet of Things. So what is Internet of people? If I want to use internet, I have to go to some like shop, you do something, you email something and you can transfer data. So initially internet was developed for people, Internet of people, people connected to internet. If you want to do send some data or transfer some email, you have to go to the shop and then you access your email or Gmail ID, etc. and you transfer message. So now what happened? People connected to internet plus things connected to internet plus things connected to things. This is Internet of Things. Things connected to internet means, as I said, that my ATM machine is connected to internet. So things is connected to internet. Now things connected to things, you can exchange. Now things are also connected to another thing, that is Internet of Things. So initially when it is created in 2010, it was for Internet of people, and later by 2020 it was Internet of Things. Now that means things are connected with other things. So what are the evolutionary phases of the internet? So evolution of the internet are generally happen in 5 phases. What are the phases? First, as I said, hosts are connected with the host. This host is connected with the host. This is the network of many hosts. Then after that, many hosts connected to these hosts. So internet, the World Wide Web is created. This all the hosts are connected to this World Wide Web, and this web, via the internet, you can transfer messages, exchange messages. And then, as we said, that this internet we can use with the help of the mobile devices. Initially there is only mobile phone, and after that you can with the help of this mobile internet you can access your Gmail, etc. in mobile phone while walking, while driving, etc. And then mobile plus people per PC. That means the identities of the peoples are now connected with mobile. Like we have Instagram account, we have Facebook account. So identity of mine is connected to some account, and that can be accessed by any other. So mobile plus people plus PC, and next is Internet of Things. Things are connected to things, like with the help of this remote or maybe your smartphone, you can connect your washing machine. Okay, so you can control your TV, you can control a smart bulb. So Internet of Things. So the evolution of internet, it begins with the connecting two computers together and then move towards creating World Wide Web by connecting large number of computers together, and then the mobile internet emerged by connecting mobile devices to the internet. Then people's identities joined the internet via social networks. Finally, it is moving towards Internet of Things by connecting everyday objects to the internet. So I think you all understood.
Ma'am, these things can share the information as well. Instead of without any interpretation of people, these things can share the information.
Yes, that's why it is Internet of
So
Things.
how
Yes.
do we control that? Means if these are sharing the information,
Which information?
like suppose my washing machine is sharing information with my remote or somebody else.
No. You have in washing machine we have embedded some programming. So that will work according to it. So you can connect your washing machine with the help of your smartphone. Okay. So in smartphone also we have some app, and with the help of smartphone you can switch on your washing machine, and also you can switch off your washing machine if required. And otherwise, if it is automatic, then it will automatically shut down. You will come to know whenever that washing machine will stop, you'll get some message that it is already, your work is over. So this no person is involving here. You are controlling everything with the help of one thing with another thing. That's why things are connected to things. Suppose I want to give water to a plant. I can control it sitting at here also with the help of internet. I can now switch on that with the help of phone. I can switch on that you sprinkle water, and after some time you can again stop it. Okay, that you can do. That is the meaning of things connected to things without the involvement of a person. Because with the help of Internet of Things, in my first slide, what I show, I want to automate everything. I don't want to go and shut the door. I want whenever I will enter, the door will automatically shut. Okay. So when I will enter, my lights will be switched on. And similarly, I can also program my AC. Like suppose I ride the bus, I am returning from my office, I ride the bus, and when I ride the bus, at that time I will set a program. At this time my AC will on, and so that when I enter my room will be cool for me. Okay. So that means without physical intervention of a human being, I am controlling things. Okay. That is Internet of Things. So where is IoT? So where is IoT? IoT, it is everywhere. So I can say that we can use IoT in Internet of Things in healthcare. We can use Internet of Things in industry automation. We can use Internet of Things in agriculture. We can use Internet of Things in smartphone. So I'll explain only the first, healthcare, how we use Internet of Things in healthcare. So everybody nowadays are using smartwatch, okay, smart wristwatch. So in this healthcare system, what we did, like not I did, like what are the applications of Internet of Things in healthcare, that in this person we have attached some sensors. So maybe I have attached some heartbeat sensor, I have attached some maybe ECG sensor, etc. BP level of a person, all the sensor I have attached, or maybe I am checking the speed of the runner, those type of sensor I have, accelerometer, gyroscope, those type of sensor I have attached, and this sensor continuously emit those information, and this smartwatch will receive all this information, and smartwatch, we don't have a more memory, yes or no? So in such a case, the smartwatch will receive all the information and send all this information to the cloud, so that the cloud will store all the information, and then it will process or analyze it after maybe 5 days or 30 days of time, that it will tell the health of the patient, or maybe health of the runner, maybe speed of the runner, how fast what is the how this runner is increasing his or her speed. Okay, this way you can analyze after 1 month. Then similarly in agriculture, so as I already said that we have used one soil sensor, and the soil sensor is testing that whether the soil is dry or not. With the help of ESP32 or maybe Arduino Uno, you can use, and you can check the reading of the sensor, soil sensor, whether the soil is dry or it is wet. If the soil is dry, then it will sprinkle. We have to use one motor, and what we need also water. The motor will give energy, and that will sprinkle water on this plant when the moisture level or the soil sensor level sense that the soil is dry. Okay. So this is smart agriculture. Smartphone I already told about, smart bulb, smart fridge, smart lock, etc. And similarly industry automation, nowadays we generally use IoT in many places in industry automation. Like I can say that whenever you are using heavy machines, you will see some noise. That machines will generate some noise, and the machines have also wear and tear. So some places the machines is like you use some sensor. That sensor will record that the life of the machine. So if suppose you have installed that machine in this year, and after how much time this machine will go die, it will sense all those things, and after analysis you can get it. So in industry automation also, or maybe suppose you are, many industry use robotic arm. With the help of the robotic arm also you can filter small components from the large components, okay, and you can store it in another bucket. So many type of works are generally use IoT in industry. Then the overall picture of Internet of Things, you can use Internet of Things in agriculture, you can use Internet of Smart Home, you can use healthcare, transportation, industry, market, school, vehicle, etc. So in traffic light also it will control automatically. When there is heavy traffic, the light will on off accordingly, okay, with the help of this IoT. So where do we see these IoT devices? Mostly in business 40%, then healthcare 30%, retail 8%, security 8%, and other 14%. So mostly we use IoT in healthcare and businesses, or maybe industry. So people and devices. So what is the people and devices? What these slides signify? Like if you see that in 2003, in this year, we have the world population was 6.3 billion, and for 6.3 billion people, 500 million connected devices were present, okay, in 2003. So what happened? So in 2010, the population increased from 6.3 to 6.8 billion, whereas the connected device increased 12.5 billion. Okay. So if you see also, one person has two mobile device. One person has one mobile device, one laptop, one maybe two mobile device, sometimes some PDA, etc. Many devices. So per people, the population increased 6.3 to 6.8, whereas the connected device with the double, 500 million, more than that, 12.5 billion. So the ratio increased from 1.84. Similarly, in 2015, these connected devices were like, it was 25 billion and then 50 billion. So the population rate increases like this, 6.3 to 6.8, 7.2 to 7.6, whereas connected devices increases to 50 billion. Okay, so one person has 6 to 7 IoT devices by 2020. So people and devices are increasing like this rate. So what are the components of IoT? So what are the components of this IoT elements? Identification. IoT is composed of identification, sensing, communication, computation, services, and semantic. So IoT elements, I will discuss one by one. What are these IoT elements? So first is identification. So what do you mean by identification? Identification means I have some device, electronic device, maybe I can say my phone, or I can use some smart bulb, or I can say some anything smart things. So every electronic product has some EPC code, electronic product codes. Whenever that is the identification of that devices, that EPC code. So how can, so I have my Aadhaar ID. Yes or no? Similarly, these devices have the EPC code for identification. Similarly, plus sensing. Each of these devices will do something. What they will do? Like sensing. So one thing is, like suppose we are human, so we have senses. We have eye, we can see, we can listen by ear, we can speak, we can touch. Okay. So similarly, whenever you are creating a IoT device, you have to put for this sense. Okay. So you have to put this sense means you have to inbuild these sensing things to these IoT devices. Okay. Yeah. So these devices can take input. So we need smart sensor. So whenever I am saying temperature sensor, that means with the help of the I can feel the temperature of this room. but how this device can feel the temperature of this room. So that device has some sensing properties. So with the help of that sensing properties, that components of that equipment can sense it. Okay. So identification, like we have Aadhaar ID, these devices have some identification. Then sensing, these parameters, like we can see, we can hear, we can touch. So these devices also have smart sense organs like actuator. Then next is actuator and wearable. So this I'll discuss. Then plus communication. So after I can see, suppose one fly is sitting on your hand. So what you sense, your brain will sense it, and after that your brain will instruct that you just touch it, or maybe somewhere you have to if you touch that fly will go. Yes or no? Similarly, we need communication. So we have to provide communication to these sensing, to these devices. So that we can do with the help of Wi-Fi or Bluetooth. Okay. Similarly, computation. So we have to also give the computation power to these devices with the help of Arduino Uno or Raspberry Pi or ESP32. I have written some program, and with the help of that program, that device will act like that. Okay, according to that program. So whenever I want to only sense the temperature, it will sense. Then I want to display that temperature. What is the temperature of this room? That will display. That we can do with the help of this computation device. For that we need hardware, Arduino, Raspberry Pi, etc. And for that we need software, Contiki operating system or Tiny operating system. So we need hardware and software both for computation. Then services. So these device will perform some certain services. Yes or no? Like smart home, intelligent transport system, smart healthcare. It will provide some kinds of services so that people can use it. Okay. The next is semantics. So semantics in the IoT, it refers to the ability to extract knowledge smartly by different machines to provide the required services. So suppose I am collecting the temperature of this room for 1 month, and after that what I'll do some analysis that whether the temperature of this room is very high or the temperature of this room at which time the temperature of this room is very low. So accordingly I will set or I will check and I will decide what to do. So after suppose the runner is checking the speed of running speed. So after 15 days or 20 days it will check, again the runner will check that its speed and whether it will increase the speed or decrease the speed, accordingly it will. So that you can do with the help of the analysis. After doing analysis you will do the required service, or you will do the required actions. So these are the 6 main components of IoT: identification, sensing, communication, computation, service and semantics. I hope you all understood. Yes. So then what are the IoT devices? As I said, sensors are fitted almost in every device, as you know. So I said about temperature sensor. Similarly, different types of sensors exist, like vibration sensor. You can check the vibration of some equipment. Then humidity sensor or moisture sensor, RFID, magnetic, electric, different types of sensors are there. So every device has unique ID. As I already said that you can identify that every device with the help of the unique ID. Okay. So now that if every device has unique ID, then how can you connect billion of devices? Because as you see that number of people increase, but number of device increase with respect to one people are using nowadays 6 devices, minimum 6 to 7 devices. So in 2003 6.3 billion, 2010 6.8 billion, 2015 7.2 billion, 2020 7.6 billion population, and with respect to 50 billion devices with respect to 7.6 billion population. So is it possible to assign addresses to all the devices in the world? If we will use IPv4 addressing, it is not possible to assign addresses to all these devices. For that, it is possible, yes, with the help of IPv6. That's why now IPv4 we shifted to IPv6 address. Because IPv6 has a huge address space, that is 2 to the power 128 address space. The address space thereafter has like this many number of, you can connect the device. Okay, this many number of addresses. So we can, it is possible to assign addresses to all the IoT devices with the help of IPv6. Then how this IoT works? Okay, so tons of data are generated from the devices. As I said that whenever you are recording the temperature of this room, if I am recording it per minute, that means in 1 hour 60 minutes we have 60 data. So per day means 24 into 60. Yes or no? So if I am recording for 15 days or 30 days, you have millions of data. So where to store this data? So where could you store this data? The answer is cloud. We can store all the data in the cloud. And the next part is, as I said, data analytics. When you will do analysis, at that time only you will identify what are the lacuna here. So data collected from the devices is quite large and complex, that becomes difficult to analyze using traditional system. That's why big data came, and analytics deals with the extraction of meaningful data from this big data. Okay, so this is big data, and whenever analytics means you are extracting the meaningful information from this big data. So what are the challenges in IoT? So these are the challenges in IoT. I'll discuss one by one. So scalability, first challenges we have discussed here, scalability. So in scalability, million of devices connected to form IoT. So I can say that, like when million of devices are connected to form IoT, how can you define the scalability? So when you have connected only 2 or 4 or 5 devices, you can exchange data very easily. But whenever you are connecting more than 5, suppose you have a connection system for 10 devices, and now you are trying to connect 100 devices. So we need some protocols for that to address this scalability issue. Then next is security. So things becomes connected, so security becomes complex. So because things are connected, if we will consider your smart home, suppose you have a smart camera inside your house, and in that smart camera you are capturing all the movements of your smart home. Okay, so those informations are your private information. So many people don't want to share those information with the outside world. So some data are private, so we have to provide privacy. We have to provide privacy with the so privacy one challenge in IoT. Similarly, security also, because these things become connected, so some of your secured information may go to some places where also you have to provide security. So nowadays this blockchain concept evolved that can provide security and nobody can theft your data. And another is, like these things are connected, like they are physical devices. So anyone can take that device, open it and take it. That is also you have to take care of. Then next is technological standardizations are required. Various protocol and architecture are developed, like some companies are developing some type of sensor, other companies are developing different types of Arduino or ESP32. All these are developed by different organizations. So we must need one, like a common standard or protocol which supports various devices. Okay, different technology leads to interoperability issue. That's why we need standardization. Recent IoT standards are helping minimizing this problem. The next is big data and data analytics. As we already discussed in our previous slide, massive amount of sensor data are like we are generating. So from different sources and from various forms. So we have to extract intelligent or meaningful information from these heaps of data, and accordingly we act. So these are the challenges in IoT. The next is the IoT architecture. So we will discuss 3 types of architecture here, although many types of architectures are available in the literature. So in first type IoT architecture, this is 3-layer architecture. where we have perception layer, network layer and application layer. And in B we have shown middleware based architecture where we have backbone network layer, coordination layer, middleware layer in between the perception layer and application layer. And next one is SOA based architecture. This is SOA based architecture, service oriented architecture. And the last one is 5-layer architecture where we have object layer, object abstraction layer, service management layer, application layer and business layer.
And so do they work like TCP IP architecture or they are working something differently?
Actually in Internet of Things, what happened? Only they try to this is only they try to develop the physical layer and the data link layer, and after that the network layer is same for both IoT and the traditional protocol, because in network layer can't change this already this routers and this World Wide Web is already their internet service providers are already exist. So only they change this lower layer, okay, physical layer, and MAC layer, little bit upper layer, the data link layer. Inside data link layer we have MAC layer. So this back layer and physical layer they change, and upper layers are almost same like other layers. That I'll discuss in our further slides.
These architectures has been used in all IoT devices.
Most of the IoT devices. As I said that here I have discussed only, I have shown only 3 or 4 architecture. Other architectures are also available. MPM architecture.
It will lead to the interoperability of the devices.
Yes. So next is first is perception and object layer. So first is object layer. We'll discuss this last one. Okay, 5-layer architecture. So first is first one we'll discuss 3-layer and 5-layer architecture. So first we will discuss 3-layer architecture. Perception or object layer. Perception or object layer means we can touch, physically sense. Okay. So the first layer object or devices or perception layer, it represents the physical sensor of the IoT that aim to collect and process information. Physical device you can touch, any sensor or physical device you can touch. That is perception layer. This layer includes sensors and actuators to perform different functionalities such as querying location, temperature, weight, motion, vibration, acceleration, different type of sensors are available. Yes or no? That is object layer, perception layer. Perception layer, what it will do? It senses all kinds of information and pass this physical information into digital information to the higher layer. So, as I said, that temperature sensor, it will sense the temperature of the room and then it passes that information to the upper layer. Okay. So, upper layer is the directly network layer. Okay. So upper layer, as I said, if you will go to the 3-layer architecture, here it is written perception layer, then network layer, then application layer. So I am discussing next network layer. So IoT network layer, it is established on the basis of the current mobile telecommunication internet. As I said that this network layer we generally don't change anything. Okay. We are using the existing architecture, so its main feature is to convey the information between a long distance. Network layer, it comprises various communication network and integrated network based on internet, which is generally regarded as the most mature part, because already network layer is developed for traditional network. We are using this same network layer we are using for IoT. So it includes the part intelligent to process the massive information. Mobile phone payment system, if you look, the suppose traditional layer exists before the development of this mobile phone payment system. Nowadays you can pay using this QR code, yes or no, or some built-in RFID information, like whenever how you pay this with the help of this mobile phone payment system. As soon as the network layer finishes the confirming of the built-in RFID information collected and uploaded to the internet through simply equipment, the payment will be conducted through bank network. So whenever you are scanning that code, that is only developed for Internet of Things. After scanning, it will directly connect it to the bank network. Already internet banking was there, and from that internet banking payment will be made. Okay, and you have to provide your password and payment will be made. So network layer is the infrastructure for IoT to provide common services. And this network layer, we have not changed anything in network layer. It is already we are using existing network layer. So in application layer, what they have changed that the application layer provides specific service to a specific department. Like when you are paying some, like with the help of this QR code, that is another one specific service. So application layer is the final goal of IoT development, software development and intelligent control technology that will offer colorful application of IoT. So the application layer, it provides the services requested by the customer, and for instance the application layer can provide temperature and air humidity measurements to the customer who asks for the data. That means suppose I want to know the temperature of this room, I can use my mobile phone, I can check the weather forecasting, that whether there will be rain or what is the temperature at this moment, I can check it. So the user will requested some certain kind of services, and that will, this application will provide that request. Okay. So the importance of this layer for the IoT is that it has the ability to provide high quality smart services to meet the customer needs. So it covers numerous vertical markets such as smart home, smart building, transportation, industrial automation, smart healthcare, etc. Then next is IoT architecture. So two best known architectures are available: one M2M architecture and IoT world forum architecture. So what are the two best known architecture? One is IoT architecture and one M2M architecture, another is IoT world forum architecture. So the goal of M2M architecture, M2 is machine to machine architecture. So it creates a common architecture that would help accelerate the adaptation of M2M application. So first M2 application was evolved, and after that one M2M architecture was developed for this IoT. Okay. Similarly, so IoT world forum architecture are also there. So the goal of one M2M architecture is to create a common service layer which can be readily embedded in the field device to allow communication with application of the services. So what happened that connecting backnet system that have HVAC and BMS run with the LoRaWAN technology that the sensor network uses. So if you see this building, in this building we have central AC. So this is generally the backnet system where we are using the HVAC and BMS run. So we have some this LoRaWAN technology sensor on each and in each room, and we can check the temperature of this room, and we can accordingly this system will control the temperature of this room. Okay. So if you need 22 degree and the temperature is 28 degree, then it will control automatically with this system, although it is not working here. Huh? So then next is one M2M architecture. It is proposed by European Telecommunication Standard Institution (ETSI). One M2M architecture divides IoT function into three major domains. One is application domain, service layer, and this physical layer. Okay. So these are the device layer. These are the devices are connected to this communication network. Again, this is suppose one type of communication network. This is another type of communication network. These two are supported by a common service layer, and this common service layer is connected to all the application. So we need standard. As I said that we need standardization. So for that they have developed this common service layer. Then next this thing. So next is IoT world forum architecture. Like our OSI layer, we have 7 layers. Yes or no? Physical, data link, then network, etc. Similarly, here we have 7 layers. Physical devices, a controller. Physical layer, you can touch. We have sensor devices, machine. You can touch. Physical layer. Then next is connectivity. We need Wi-Fi connection, Bluetooth connection. That is connectivity layer. Then edge computing. All these devices sense all these with the help of this communication provided internet. It will transfer this data to this layer, edge computing. Then here data accumulation, you are storing the data. Then data abstraction, your analysis, doing analysis, then abstracting data. Then we are providing some application or support services, and then collaboration and process again. Okay. So these are the 7 layers of this IoT world forum architecture. So one is physical, physical layer, then connectivity, edge computing, data accumulation, data abstraction, application. I will also discuss in my further slides. So, layer 1 is physical devices and controller layer. Home of things in IoT things can be from microscopic sensor to giant machine in a factory. This layer 1, these are sensors, devices, edge nodes of all types. So it is devices and controller layer, and the data in the physical layer, then capable of being. The next is connectivity layer. Connectivity layer, we need router, switches, etc., which will collect all this information. And then in layer 3, which is edge computing layer, like transfer to the edge and fog. Transfer to is the fog layer. It gives emphasis on data reduction and data flow. Data reduction means if I am continuously sensing data, and if for my temperature this room are same, use that data and I will say that from for 30 minutes the temperature. Okay, so this is reducing. Okay. Then next is data 4, data accumulation. Capture data and store it for application. Then data abstraction, reconciles multiple data format, ensure consistent semantics for various data sources, confirmation about data set, completeness. Then next is application. Interpret the data using software application, and then you provide the services. Then collaboration, process lab, consumes and share the application information, collaborating and communicating IoT information. Okay, so this ends with all the layer. Thank you all. So now if you have any doubt, you can ask me question.